Okay. Okay. Module 4, basic exponent rules. Probably most of you haven't started on module 4 yet. If you have, hopefully this is helpful for you. Basic exponent rules. Six to the third times 6 to the second. Anytime you've got the same base, in this case, 6 and 6, if you're multiplying the same base, you just add the exponents. If multiplying the same base, add exponents. So it's pretty easy. 3 plus 2 is just going to be 5. And I think in most cases, if the 6 to the 5th is going to be a pretty large number, in most cases, they'll just let you put 6 to the 5th. They'll have a little box above the 6, and you just put a 5 in there. That's all you have to do. One little one, you might not need this example, but I figured I'd show it anyway. Here, these are the same base, multiplying 3 and 3. The exponent on the 3 is what? 1. So that's all you got to remember. So this one's going to be 3 to the 7th. And by the way, I didn't mention this before, but the dot in between the two numbers is multiplication. You'll see sometimes the dot, sometimes you'll see the little X in the middle, which is the way you guys are probably used to seeing a lot of multiplication, 3 to the 2nd times 3 to the 4th, something like that. But we'll go further and further away from using X as multiplication because you're going to use it as a variable. So you don't want it in there confusing whether or not it's X as a variable or whether it's X as a multiplication. So if it does have the times in the middle, like an X, he's just doing the same thing. So this would be 2 plus 4, which is 6. Okay, so multiplying the same base, you add exponents. Next, we'll look at 4 to the 4th over 4 to the 3rd. A fraction is basically a division problem, 4 to the 4th divided by 4 to the 3rd. If you're dividing the same base, here the base is 4. If you're dividing the same base, when you're multiplying, you add the exponents. When you're dividing the same base, you're going to subtract the exponents. So this becomes 4 and then 4 minus 3. Four to the first. If they've got a little box up there next to the 4, you can just put a 1 in there. If they're asking for just the answer, 4 to the first is the same as 4. So there might be some variation in how they want you to put that in there. 4 to the first or 4. Three to the 7th over 3. Again, you've got that invisible 1 on the 3 on the bottom. So if we're dividing the same base, we're going to subtract. This is going to be, so the same base, which is 3, and then we're subtracting those exponents, 7 minus 1. 3 to the 6th. And if you, I mean, in some cases, they may want you to expand that. You can put that in your calculator. I can show you guys how to do that. 3 times 3 times 3 times 3. You wouldn't want to do it that way, but there's a quicker way to do it. 3, and then there's a little sort of an upside down V that you can put a 6 in and then equals, and it'll spit out the answer for you. Okay, and then the last one in that section, 5 to the 4th to the 2nd. Here, basically what you're doing is you're taking an exponent to an exponent. You're raising a 4th power to the 2nd power. All you've got to do here is multiply these. Five to the 8th. And again, if they want you to expand on that, sometimes they'll have a 5 and then a little box up to the top right. You just put 8 in. If they want you to expand that, you can just put that into your calculator and see what that spits out. I'll go ahead and do that here. 5 to the 8th power ends up being, I doubt they'll have you do this, 390,625. Okay, next section, multiplying powers. We've got 16x to the 5th, y to the 5th, and then in parentheses 9y to the 4th. Some of these are going to look kind of complicated, but if you just think of, you know, everything is butted up against each other, which means we're multiplying. They give you a hint of that in the title of the section. So if you're multiplying 16 and 9, that's pretty easy. You can do that on a calculator. 16 times 9. Number-wise, you get 144. And the x doesn't have anything to multiply with, x to the 5th. So it stays as x to the 5th. And if we're multiplying y to the 4th, or y to the 5th and y to the 4th, we're going to do the same thing we just got done doing. If you're multiplying y's, same base, you add the exponents. So this is going to be y to what power? 9 power. Yep, just adding the 5 and the 4. Add exponents if you're multiplying the same base. If there was another x in there, we'd do the same thing with it. Maybe it would be x to the 3rd, and we put x to the 5th and x to the 3rd together and get x to the 8th. So just multiply the numbers and then add the exponents of the variables. Negative 2x to the 5th, y to the 2nd, times negative 14 y to the 2nd. So here multiplying negative 2 and negative 14, negative times a negative is positive. 2 and 14 is positive 28. How many x's do we have? 5. How many y's? 13xy squared times negative 9x to the 4th y. 13xy squared times negative 9x to the 4th. On your calculator, you can do 13 times negative 9. Negative 117. Make sure you don't forget that that x there does have an exponent. You might pencil that in. It's x to the 1st. Also, that y on the end there, that has an exponent also. And if we're multiplying x's, we add the exponents. Multiplying y's, add those exponents. So we've got x to the 5th, 1 plus 4. And we've got y to the 3rd. Raising power is 2 powers, -4 x squared y to the 5th, all that in parentheses to the 3rd. On some of these, I would think you'll probably want to use a calculator just to double check things. But what we're going to do is we're going to multiply each exponent inside by 3. Multiply each exponent inside by 3. So, by the way, what's the exponent on the 4? 1. So that's also going to multiply by 3. So it's going to be, just going forward, -4 to the 3rd. I'm going to put the -4 in parentheses. -4 to the 3rd, x to the 6th, y to the 15th. So multiplying each exponent, so the 2 times 3, the 5 times 3, that's how we get the 6 and the 15. Okay, and all I did there on that last step is expand the -4 to the 3rd. -4 times -4 times -4, you end up with -64. Okay, make sure you guys stop me if you have any questions. Mm-hmm. Okay, multiply each exponent inside by 3. Oh. Okay. -6 x to the 2nd, y to the 4th to the 4th. So a lot like the last one. Multiply each exponent inside. What are we multiplying each exponent inside by here? 4. So I'm going to write -6. I'm going to put that in parentheses to the 4th, because don't forget it has a 1. That's the error I see most commonly. People forget that I need to take the -6 to the 4th. They do it with the x and with the y. They multiply those exponents, but they don't multiply that invisible 1. So this is going to be x to the 8th, 2 times 4, and then y to the 16th. Be careful you don't put 8. Because you'll have some sections where all you're doing is adding exponents, and then here, multiplying. So this is going to be 36. So if you put -6 to the 4th into the calculator, and you're going to want to be careful on that one, you need to put the parentheses around the -6. Otherwise, if you just do it like this, if you type this into a calculator, -6 to the 4th, what it'll do is it'll do 6 to the 4th and then throw a minus in front of it. You've got to let it know that -6 is what's being raised to the 4th. So it's not doing 6 times 6 times 6 times 6. It's doing -6 times -6 times negative. You'll sometimes get a different answer, especially if it's an even. If it's an odd exponent, it doesn't matter. But if it's an even exponent, you have to have parentheses around it. Otherwise, the calculator is not going to give you the right answer. So just to be safe, it's probably a good idea to always put parentheses around those negative numbers when you're raising them. Okay, so that's it for that section. Dividing powers. 9x to the 8th, y to the 7th, over 9x to the 6th, y to the 7th. So again, a fraction is just basically a division problem, the top thing divided by the bottom thing. A little shortcut on some of these. If they give you the same thing on top and bottom, you can go ahead and put a line through them. You can cancel the 9s here. The y to the 7th, it's exactly the same on top and bottom. You can go ahead and cancel those. So I'm going to go ahead and do that. These are called factors. If exactly the same factor on top and bottom, cancel. If you've got exactly the same factor on top and bottom, cancel. So 9s we can get rid of, y to the 7th we can get rid of. And then we're left with just the x to the 8th and the x to the 6th on bottom. And if you remember when we had that before, dividing the same base, are we adding the exponents or are we subtracting them? Subtracting them, yeah. If you've got a fraction, subtract those exponents. So this is going to be x to the 8th minus 6. Just end up with x to the 2nd. And maybe on this right, I'll write x to the 8th over x to the 6th, since that's what we had after we canceled. X to the 8th over x to the 6th, subtract those exponents, left with x to the 2nd. (27) x to the 8th, y to the 5th over 18 x to the 7th, y to the 8th. So again, like the last one, if you've got the exact same thing on top and bottom, you can go ahead and cancel those. You'll see several examples where you can do that. This one though, nothing that's exactly the same. You don't have 27 on bottom. We don't have x to the 8th on bottom. So just a reminder of what we're doing with the 8 and the 7, we're going to subtract those exponents. With the 5 and the 8, we're going to subtract those exponents. So one thing I want to kind of highlight really quick, you don't necessarily have to write this down, but I hope you can kind of conceptualize this. The y to the 5th on top really just means y times y times y times y times y, right? We got 5 y's being multiplied on top. On bottom, we've got 8 y's being multiplied, okay? So like I said, you don't have to write this down, but hopefully you can kind of picture this in your mind. So if you've got the exact same thing on top and bottom, you can cancel. So we've got a y there and a y there that's gone. Y there and a y there that's gone. When you do if we look back at the 5 and the 8 over here, and you can subtract those in your head. 8 minus 5 is 3. Minus 3. But I was going to say, though, if you just do 8 minus 5, you get 3, but you have to realize those 3 are going to be on bottom. Because if you cancel, those 3 y's are just going to be left on bottom. Whereas if we did the 8, the x to the 8th and the x to the 7th, you have 8 x's up top, 7 x's on bottom. All the similar ones cancel, and you're left with 1 on top. So 3 y's on bottom. So you can do the subtraction. 5 minus 8 give you -3. Slightly different ways you can think of this, but hopefully you should recognize that the y's are going to be on bottom. So on this one, since we're going to have y's on the bottom, y to the third on bottom. And then that x to the first, the 8 minus 7, we're doing the x's, going to be on top. And then the 27 and the 18, we're just going to reduce those. So if you're reducing 27 and 18, you want to think, well, what do they have in common? 9 goes into both. Yeah. So reduce by 9. 27 divided by 9. 3. 18 divided by 9. 2. Okay. And then when you enter this in the computer for your answer, you're not going to put x to the first. Typically, we don't put x to the first or 4 to the first or anything like that. You just put x. So I'm going to go ahead and delete that. I'll do one more of those. 30x to the second, y to the fourth. Then on bottom, 50, x to the eighth, y to the sixth. 30x to the second, y to the fourth, over 50x to the eighth, y to the sixth. I'm gonna highlight the x's and y's. I'm gonna subtract those exponents. And you can think of it as 2 minus 8, that's fine. You can also think of it as 8 minus 2. 8 minus 2 would be 6, but our x's, are they gonna be on top or bottom? Bottom. We're gonna have 6 x's on bottom. And when we do the y's, if you think of it as 6 minus 4, you're gonna have 2 y's, and then hopefully you recognize, since we've got more y's on bottom, those 2 y's are gonna stay on bottom. So go ahead and put a line. X to the sixth is gonna be on bottom. Y to the second is gonna be on bottom. 8 minus 2 is 6. 6 minus 4 is 2. More x's on bottom, more y's on bottom. And then the 30 and the 50. What would we reduce that by? Yeah, anything that has a 0 on the end, you can reduce by 10. So 30 reduced by 10 is 3. 50 reduced by 10 is 5. And sometimes you might get these new numbers, and you'll notice that they can reduce also. If they can reduce, just do another step. You know, if it were 6 and 10, maybe you reduce those by 5, not realizing that 10 is a larger common factor. If you had 6 and 10, both of those reduced by 2, so you'd want to go a little bit further. But 3 and 5 don't have anything in common, so go ahead and stop there. Negative and 0 exponents, level 1. It's one quick thing here. Anything to the 0 power is 1. Anything to the 0 power is 1. If you've got 4 to the first, that's obviously going to be 4. If you have 4 to the 0, though, it's just going to be 1. It's not going to be 4 to the 1. 4 to the 0 is just equal to 1. It won't give you any examples like that exactly, but you might see something like 3 to the third to the 0. And hopefully you remember from the previous section that we're going to multiply those exponents. If you've got an exponent being raised to another exponent, you multiply those. Three times 0 is just 0, so this ends up being 3 to the 0, and 3 to 0, same as 1. And by the way, the instructions will say the same thing on most of these. It'll say which expression is equivalent to, in this case, 5 to the negative 4 to the negative 6. 5 to the negative 4 to the negative 6. So on some of these, it's just another exercise like in the previous section. So negative 4 times negative 6, negative times negative is positive. 4 times 6 is 24. So I'm using these quotation marks down here just so I don't have to rewrite which expression is equivalent to, but I'm just, these quotation things just mean we're repeating the same thing. Which expression is equivalent to 2 to the negative 8 over 2 to the second. Two to the negative 8 over 2 to the second. So on the last example, we multiplied the exponents. Here, subtracting exponents. Since that's a negative, we're going to subtract the exponents, but negative 8 minus 2. Negative 8 minus 2. Negative 8 minus 2 is negative 10. And what we'll do is we'll make negative exponents positive by moving the base through the fraction line. So I'll give you a second to write that. Make the negative exponents positive, which you'll have to do. It's going to want you to put in all your exponents as positive. Make the negative exponents positive by moving the base through the fraction line. So here there's an invisible fraction line underneath the 2. So I'll do this in yellow. It's invisible, right? Anytime you have, you don't have to write this down, but anytime you have a number like 10 that doesn't look like a fraction, you can write it as a fraction. This would be 10 over 1. The fraction line is always underneath that number. So basically what we're going to do is we're going to take this, the base is 2. So we're going to move it through the fraction line. And I usually describe the fraction line as kind of like a car wash. You take something negative, it goes through the fraction line, becomes positive on the other side. So ultimately we end up with the fraction line with 2 on the bottom, and then the exponent's positive 10. If there was nothing else up top, we're just going to put a 1 there. So we've got a positive exponent now. Keep in mind that you can expand that 2 to the 10th, and they may want that. They're going to go back and forth, 2 to the 10th sometimes. Sometimes they're going to want to know what 2 to the 10th is, which is 10 or 1024. Which, if anybody doesn't know how to do exponents on their calculator, I can come around and show everybody. So either one of those, but they'll have multiple choice on these. So if you don't see 1 over 2 to the 10th, look for 1 over 1024. Four to the negative 2 to the negative 1. Multiplying those exponents again. So negative 2 times negative 1. This is going to be 4 to the positive 2. Is that going to be 8? Yeah, be careful. 5 to the second, I see people write 10 a lot. 4 to the second, I see people write 8 a lot. So just keep in mind, that's 4 times 4. So again, write the expression equivalent to, so same instructions on all of these. 5 to the 0 times 5 to the negative 4. Five to the 0 times 5 to the negative 4. Multiplying the same base, adding the exponents. Another way to look at this, there's some slightly different ways you can look at it. 5 to the 0 is 1, really. So you can think of it also as 1 times 5 to the negative 4th, which is going to be 5 to the negative 4. Sometimes it won't be 0 though, and you're still going to be adding those exponents. 0 minus 4 is negative 4. Not going to put any negative exponents into the final answer. You got to make that exponent positive. Make exponent positive by moving through the fraction line. Same thing we wrote down on the previous one. Make exponent positive by moving through the fraction line. So you've got an invisible fraction line underneath the 5. So this is going to go through the fraction line. It's going to become positive on the other end. So 5, what's the exponent on the 5 now? Positive 4, and then what goes on top? And they'll give you multiple choice. Maybe it's 1 over 5 to the 4th, or let's see, 625, all right. Or so which expression is equivalent to 3 over 3 to the 4th. 3 over 3 to the 4th. Keep in mind there's an invisible 1 there. Dividing, subtracting exponents. So 1 minus 4. So 3 to the negative 3, got a negative exponent. We're going to make that positive by moving it through the fraction line. It's negative, goes through the sort of car wash, positive on the other end. 3 to the positive 3 on bottom, throw a 1 on top. And this is one that I would expect that they would have expanded. 3 to the 3rd, it's not 9. That's another one. Be careful about that. 27. 3 times 3 times 3. Okay. Okay, I'll stop there for a minute. I've got some more examples I want to look at before today's over. Let's see. Okay. Exponential rules level 1. Two, and then in parentheses, p to the 2nd to the 5th, and then 5p to the 5th. Here we're going to, just like we did on the previous one, we're going to multiply each exponent inside by 5. Multiply each exponent inside by 5. So that means that this 1 that's on the 2, we're not going to multiply by 5, just the things that are inside the parentheses. So that 2 to the 1st is going to stay 2 to the 1st. But this is going to be p to the 10th now. Okay? So 2 to the 1st, still 2 to the 1st. And then on bottom, we've got 5p to the 5th. And then the only thing left to do, if you've got p on top and p on bottom, you remember what we're doing with those exponents there? Subtracting them. And by the way, 10 minus 5 is 5. Would those p's be on top or bottom? Top, right. So the 2 and the 5 don't reduce. And no p's left on bottom. All those 5 p's that are left are on top. Do one more of these. 2q to the 3rd to the 5th over 5q to the 5th. Two q to the 3rd in parentheses to the 5th. Exponent on the 2 is a 1. Are we going to take that 1 times 5? on this one? Well, let's go back to the last one. You're going to multiply each exponent inside. Each exponent inside the parentheses times 5. On this one, this time the 1 is inside the parentheses, so it's going to be multiplied by 5 also. So this is going to be 2 to the 5th, 1 times 5, and then q to the 15th. Okay, so 2 to the 5th, if you put that in your calculator, you should get 32. With the q's, going to subtract those. 15 minus 5 is 10. Those 10 are going to be up top. No q's on bottom anymore. Just that 5. 32 and 5, do they have anything in common? 1, that's it. 5 doesn't go into 32, so we can't reduce those numbers. Exponential rules level 2. Exponential rules level 2, negative 2r to the negative 3 all in parentheses to the 3rd power, all over 10r to the negative 2. And make sure when you're writing this, you're not writing r minus 2 on bottom. It should be r, and then the negative 2 is what's called superscript. It's up a little bit higher. So again, we're going to multiply each exponent inside by 3. Multiply each exponent inside by 3. So try not to forget that the 2 has an exponent on it that's going to multiply by 3. So we've got negative 2 to the 3rd, and then r to the negative 9. (10r to the negative 2). If we just look at the negative 2 to the 3rd for a second, negative 2 times negative 2 times negative 2. Negative 8. That's all I'm going to do on this first step, just negative 8. And then for the r's, we're going to subtract. So this is negative 9 minus negative 2. You're subtracting whatever the exponent on bottom is. Negative 9 minus whatever the exponent on bottom. And so what that means is negative 9 plus 2, which is negative 7. So this is going to be negative 8. The r's, when you subtract them, you end up with r to the negative 7. 10 on the bottom. So a couple things we'll have to do. I'm just going to do one thing at a time, though. The r to the -7 has to become positive. So that's going to go through the fraction line in order to become positive. And that's going to be r to what power on the bottom? 7. And what would we do last? Simplify. Yeah. We've got 8 and 10. We can reduce those by 2. So reduce by 2. So -4 and then 5r to the 7th.
So only your exponent goes through the fraction, like you don't.
Yes, only the base. Yeah, that's a good question. Yeah, just that part. Because the exponent on the -8 is what? Well, the exponent on the -8 is 1. Yeah, so if it's got a positive exponent, it stays put. If it's got a negative exponent, just at the end, because over here with the -9 and -2, you can subtract. And then when you end up with your final version of r, it may need to move. Okay, doing roughly the same thing. Right, still exponential level 2. So you might put a 1 next to the 5, just so you know which exponent it is. Taking all those exponent inside times 2. Not doing anything on the bottom. Let's multiply. Multiply the exponents inside by 2. So I'm going to do two things at the same time here. -5 squared is going to be +25. When we do the w's, I'm going to write that as w -10 minus 2. Does that look right? Right. Yeah, so we will have to add 2. You're subtracting whatever the bottom exponent is. So subtracting -2, which will make it a plus. -5 on the bottom there. So we've got 25, and then w to the -10 plus 2 is -8.
That 2 should be a regular 2 minus 10, 2.
This one here?
Yeah.
Yeah, if you're subtracting a negative, it's just a plus. So -10 plus 2 gives you -8. And we can reduce these 5s or these 25s by 5. You said w to the 8th, is that what you said? Yep. And you do have when you reduce by 5, this is still -1 on the bottom. I would probably just move the minus out front. I don't exactly know how the software is going to take it if you leave the minus on bottom. It might be fine with that, but typically minuses on the bottom, you'll want to move them out front or move them up to the top. I don't know that that'll happen very often. Okay. I'll go ahead and stop there for now.